Now, let us solve the integral of cosine to the power of 6 of x. So, firstly, it is to identify whether the exponent here is an odd or an even integer. What we have here is 6, so that makes it an even integer. The rule for this is that cosine to the power of n of x, transform this into this 1 plus cosine twice of whatever value of x is over 2 and raise this to the power of n divided by 2. And so what we have here is cosine to the power 6. So we will transform this. This would be 1 plus cosine twice. Our value of x here is simply x. So this would be 2x over 2. And here is equivalent to 6. So 6 divided by 2 would be 3. The next step would be to distribute power of 3 between this first one and second one. So this would be 1 plus cosine 2x to the power of 3 over 2 to the power of 3. 2 raised to the power of 3 would be 8. And so we can put 8 outside the integral. So this would be 1 over 8 integral of 1 plus cosine of 2x to the power of 3. Let us now expand this expression. Now, let me just rewrite this. A plus b raised to the power of 3. This would be equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Let a here be 1 and b be cosine of 2x. And so, with that regarding, this would be 1/8 integral of 1 cube, which is simply 1, plus 3 times 1 would be 1. B here is cosine 2x plus 3. 3 times 1 is simply 3. B squared would be cosine squared of 2x plus b cube, which is cosine cube of 2x dx. Now that we have this expression now, let us split this into two parts first for simplification. This would be the first part and this would be the second part. Let me just rewrite the first part. It would be 1/8 integral of 1 plus 3 cosine 2x plus 3 cosine squared of 2x of dx. And the second part would be 1/8 integral of cosine cube of 2x dx. So, let us focus now on this first part right here. As you can see here, we have an expression of cosine, which is also an even expression, such as this. And so, this rule applies to this one also. So, we can rewrite this. Plus 3 cosine squared of 2x. Transform this into this. This would be 1 plus cosine twice of x. The value of x right here would be 2x. So 2 multiplied by 2x, this would be 4x over 2. 2 divided by 2 would be equal to 1. And so we can distribute 3. So this would be like something like this. Plus 3 multiplied by 1 would be 3, plus 3 cosine of 4x divided by 2. Actually, we can just split 2 in here. So this can be 3 over 2 plus 3 cosine 4x over 2. Of dx. And so we can add 3 over 2 and 1. 3 over 2 plus 1 would be equal to 5 half plus 3 cosine of 2x plus 3 cosine of 4x over 2 of dx. So we can split this integral apart for simplification. So this would be 1/8 integral of 5 over 2 of dx plus 1/8 integral of 3 cosine 2x dx plus 1/8 integral of 3 half cosine of 4x dx. Now, let us focus on this first one first. Put 5 half outside the integral, and so it will be multiplied by 1/8. 1/8 multiplied by 5 over 2 would be 5 over 16, and the integral of dx would be simply x. We are now done with this first part. Let us focus on this second part, which is 1/8 integral of 3 cosine 2x dx. We can first put 3 outside the integral. So this would be 3 over 8, and multiply this by the integral of cosine 2x dx. For this part, let u here be 2x, and so derivative of 2x would be 2 dx. dx right here would be equal to du over 2. And so by substituting it, we would have integral of cosine u multiplied by dx, which is du over 2. We can put 2 outside. So you would have 1/2 integral of cosine u du. And so the integral of cosine of u would be sine of u. And since u here is equal to 2x, our answer right here would be equal to sine of 2x. We can also multiply 1/2 and 3/8, which would be equal to 3 over 16 sine of 2x. Now that the second integral is done, we can now focus on this third one right here, which is 1/8 integral of 3/2 cosine 4 of x dx. So first, we can multiply 3 over 2 and 1 over 8, which would be 3 over 16. And now we can focus on integral of cosine 4x dx. So let u here be 4x. Derivative of 4x would be simply 4. Multiply this by dx. And so dx right here would be equal to du over 4. Substituting this, we would have integral of cosine of u multiplied by du over 4. And so, putting 4 outside the integral, we would have 1/4 integral of cosine u of du. And so, the integral of cosine of u du would be simply sine of u, and since u here in this case is 4x, this would be sine of 4x. Don't add the constant of integration yet, because don't forget we still have this other part to solve. And so 3 over 16 multiplied by 1/4, this would be 3 over 48 of sine of 4x. And so let me just write this into this bottom for simplification later. Take note that the answer for this particular integral would be equal to this one. So let us now move on to this other part of the integral. Now, as you can see here, the exponent now is an odd exponent. The rules for this would be to transform this into its trigonometric identity. Cosine squared of x would be equal to 1 minus sine squared of x, or sine squared of x would be equal to 1 minus cosine squared of x. But since we're talking here is cosine, this is the one that we will use. But as you can see in this problem, our variable here is 2x, but what we're needing here is simply x. So what we're going to do here is to substitute a variable that is singular. We can use any, but we'll just use u substitution here for simplification. So let u here be 2x. So derivative of 2x would be 2 multiplied by dx. Dx right here would be equal to du over 2. So substituting this, we would have 1/8 integral of cosine cube of u. Dx right here would be equal to du over 2. Putting 2 outside the integral, you would have 1 over 16 integral of cosine cube of u du. Now, it will now fit the description right here. It doesn't matter whether x here is a variable or a u or any variable, as long as it is a singular variable. But what we need here is a cosine squared of x, so we need to factor out 1 cosine u here. So this would be 1 over 16 integral of cosine squared of u multiplied by cosine of u du. And so we can now transform cosine squared of u according to this. So this would be 1 over 16 integral of 1 minus sine squared of u cosine of u du. Next step would be to substitute. Let a here now be sine of u. Derivative of sine of u would be cosine of u du. Substitute this, we would have 1 over 16 integral of 1 minus sine of u here is a squared. You can see here cosine u du is the same as dA. We can now integrate this. Integral of 1 dA would be simply a, and integral of a squared would be a cube over 3 plus constant of integration. Substitute a back into its original form. So a here is sine of u here is 2x minus sine cube of 2x over 3 plus c. And so the final answer for this particular integral would be equal to 1 over 16 sine of 2x minus 1 over 16 times 3 would be 48 sine cube of 2x plus c. So this is the particular answer for this integral right here. So in order to just know the full answer for this integral of cosine to the power of 6, we will just add these two together. And so we must first simplify this. You can see here we have a common term of sine 2x and another sine of 2x right here. So we must add their coefficients together, or simply the number besides them. And so the final answer for the integral of cosine to the power of 6 of x, this would be 5 over 16x plus 3 over 16. Wait, I forgot. 3 over 16 plus 1 over 16. This would be 4 over 16, or 1/4 if you reduce it. Sine 2x plus 3 over 64 sine 4x minus 1 over 48 sine cube 2x plus the constant of integration.